Okay, so we've talked about the fact that integration is the process that we go through to find the area underneath a curve. Now, once we get out there into the real world, unfortunately, not all areas and not all problems that we're going to look at are given by a beautiful, simple mathematical curve. So if you're talking about the area of a property that is bounded by a river or a lake or something that's not a nice straight line, then you can't work out the area exactly. But what you can do is approximate it. And one of the ways that we approximate an area is by using shapes that we're aware of, like trapeziums. So today we're looking at the trapezoidal rule. Okay, so you can see here we've got this area. It's going from A to B and then up to this curve. Now in this case, I have the function 1 over x, but we're not always going to know what that is. That's fine. And what I want to do is use a trapezium to approximate that area. Okay, so if I put a trapezium on there, you can see that it's going to give me an answer, and that's fine. And it's going to give me some idea of what's happening, but it's not going to be very accurate, is it? Because we've got all this area in between the edge of the trapezium and the curve that is wrong. Okay, so it depends on what your function is. If you've got a function that is pretty close to one trapezium, then that's fine. You're going to get a pretty good approximation. But in this case, it's not going to be terribly accurate, okay? And if you owned a block of land and the council were charging you rates that are based on how large that block of land is, you'd be a little bit upset that they were overestimating your area quite so much. So one of the ways that you can make this more accurate is, instead of just going from A to B and having one big trapezium, is to say, well, hang on a minute, if I go, say, every metre, then I can cut this shape up into some smaller, nice little trapeziums, because I can measure this distance, and I can go another metre and measure this distance, and then I can go another metre and measure this distance, and I can make a bunch of little trapeziums. And then when I add those trapeziums together, you can see this blue area is a much more accurate measurement for the area of that block of land than that one big trapezium. Okay, so in general, the more trapeziums you use, or the more measurements that you use, the closer your approximation is going to be, because it's going to take into account the variation in the shape of your curve. Okay, so that's the theory behind what you're about to see. So you'll see there in red, we've got this little FS. What that means is that this formula is on your formula sheet. So you do not have to memorize this, but you do need to know how to use it. So if we are trying to approximate some integral from A to B, so there are endpoints, yeah, from A to B of some function of x, okay, then the way that we do that is we do b minus a, which is going to give us that length of our trapezium, over 2 outside of f of a plus f of b. Well, what does all that mean? Well, what's the area of a trapezium? The area of trapezium, you add your parallel sides, well, that's fa and fb, isn't it? Okay, you halve it, and then you multiply it by the height. The height is b minus a, fa plus fb, the parallel sides, and then we halve it. So this is just a really complicated way of writing out the area of a trapezium. All right, so what does this look like in question form? Here's your example. Approximate the integral from 1 to 5 of 1 over x dx using the trapezoidal rule with A, 1 application, or B, 4 applications. So that relates back to our diagram. Okay, the green is 1 application. That's 1 trapezium. Okay, so for 1 trapezium, we need 2 function values. We need to know this height, and we need to know this height. 2 function values, 1 trapezium. Okay, when it said 4 applications, that's the blue one, because we're cutting it into 4 trapeziums. If it says 6 applications, they want 6 trapeziums. If it says 2 applications, they want 2 trapeziums. Okay, think about how many function values you need. For 1 trapezium, you need 2. For 4 trapeziums, You need 5. 1, 2, 3, 4, 5. So if they were 2 trapeziums, you're going to have 3 function values. It's always going to be one more function value. Read the question carefully, because they could tell you how many applications, they could tell you how many trapeziums, or they could tell you how many function values. Okay? Draw a picture if you're unsure of what it is they're asking you. So back to the question. So for one application, what we want to do is say, well, what are those values that we need? Okay? So we know that A, our starting point, is 1. We know that B is equal to 5. And then we have to say, well, I know what x is. That's the 1 and the 5. What is f of x? So a table is always a good idea when you are talking about the trapezoidal rule, because it's going to be pretty easy to substitute in the wrong values. Okay, so we want 1, we want 5, and our f of x is 1 over x. That's given to us in this one. So 1 over 1 is 1, and 1 over 5 is 1 over 5. Okay, so to approximate our integral from 1 to 5 of 1 over x dx with one application, we say, well, that is equal to b minus a. So 5 minus 1 all over 2 outside of f of a, which is 1, plus f of b, which is 1 over 5. All goes into a calculator, and I'm really sorry, but that should be an approximately equal to sign. 2 2/5. Okay, so we are saying that the approximate area from 1 to 5 of 1 over x gives us 2 2/5 units. But we saw that that green one is not a good approximation. There's quite a bit of error involved in that calculation. So we're going to do a better approximation, and we're going to use 4 trapeziums. Okay, so again, this is why it's really important to have that nice little table. Okay, so we've got f of x. Now, because we're cutting it up into 4 and it goes from 1 to 5, that works really nicely. It goes up by 1 each time, doesn't it? So 2, 3, 4. Nice and simple. Not always going to be quite so simple. You are going to get some where you have to cut them up into fractions and things like that. If you're unsure of what you should be cutting it up into, draw a picture. It's amazing how much simpler things are if you can see them. Okay, now f of x is still 1 over x. So 1 over 1 is 1, 1 over 2, 1 over 3, 1 over 4, and 1 over 5. Okay, now think very carefully here. What is your b minus a now? Well, b minus a is from 1 to 2, from 2 to 3, from 3 to 4, from 4 to 5. Yeah, so it's always going to be 1 over 2. Okay, so when we're approximating the integral from 1 to 5 of 1 over x dx using 4 applications, what we're doing is we're saying, well, we start at 1 and we go to 2, and then we go from 2 to 3, etc. Okay, and then we say, well, that is approximately equal to b minus a over 2. We've just worked that out as being a half, right? So it's equal to a half outside of fa plus fb. So it's the first function value plus the second function value plus a half outside of the second function value plus the third function value. And on we go. It's just the same thing repeated over and over again. And that's why having it in the table is so easy, because you just start on the left and you work your way across. Okay? All that goes into your calculator, and we say, well, that is approximately 1 and 41 over 60. Now, the more often they want you to apply it, the more you're going to have to do. It's that simple. HSC, they're not going to ask you to go much more than 4, because, I mean, if you can do it 2 times or 3 times, you can do it 8 times. It's just the same thing. There is a general rule that you can learn for repeated applications if you want to. All right, you do not have to learn this rule. You can just do it as you've seen me just do there and just keep adding them each time. But if you like to learn rules, no worries. From b to a of some function, it is approximately. Now, we're going to have a b minus a over 2 because going back up to that one we just did, that half is in front of all of them. Okay, so you can just pull that out the front. Now, the first function value, that 1 over 1, appears once. So if it's f of x. Oh, try that again, sorry, f of a. Now, the second function value, that half, we use it in the first set of brackets, we use it in the second set of brackets because it's one value in the first trapezium, it's one value in the second trapezium. Doesn't affect any of the other trapeziums though, does it? So it's 2 times the next value, and then it goes on 2 times the next value, and it keeps going like that right up until you get to b, because that's only used on the last trapezium. So if you like, you can learn that formula. Totally up to you. I don't suggest you learn another formula, but if it works better for you, that's fine. Alright, so that's what you need to be able to do exercise 3.1. I would like you to do the even numbers in that exercise at the very least. If you need more practice, then have a go at the odds, but you've at least got to get that done. Good luck, and I'll see you in class.